All right, here's 1-7, day 1. First section that will split up over a couple of days. Otherwise, it would be kind of a lot to cover. All in one, but the topic is inequalities. Okay? As opposed to equations, sometimes we get kind of used to working with equations, but a lot of times in functions, you end up working in a situation where you have an inequality instead, which is basically instead of saying that the two sides of your expression are the same, that one is bigger than the other. That's kind of the idea. The first thing I want to talk through is using interval notation. Instead of less than or greater than, okay, which we'll use. I'll show you both in these next couple slides. You would use kind of a spoiler alert on the bottom there. Brackets and parentheses. Now, I'm showing you this interval notation just so you have both. At the end of the day, I really don't care in terms of like an inequality with x with like a less than greater than symbol or interval notation. Use whichever one you want, okay? Understand, it's two different notations of saying the same thing. So it's not a big deal. All right, brackets look like this if you're using them, okay? And then the parentheses look like this. Now right here, those numbers that'll be there, those are your boundaries. It might be bounded on both sides. It might just be bounded on one side, okay? Now, the really big difference between these two, all right, for these boundaries, or you could think of them like, endpoints. I'll put that in there, the boundaries that make up the interval. You could hear those referred to just as endpoints. If you have brackets, that is telling you your solutions to the inequality would include your endpoints. Almost predictable at this point. If you have parentheses, do not include endpoints. Obviously this is kind of just going over some of the basics of writing solutions to inequalities in this notation. We need to see some examples of like, okay, what does this look like with some actual numbers? Okay, x greater than or equal to 3, okay? I just like to throw a little, just to have a visual. This is not like the actual interval notation. I'll try to just throw this on a number line. Right, there's 0. There's 3. And so this is saying, including the point 3, mark that. This is all of those x values, okay? But now in the notation I'm talking about, here's what I would say. There's a boundary that you include 3 on the left. Okay, that's where it starts. The right side, we say, is unbounded, and the other slide made it seem like, oh, you just need another number to say where the interval ends. Well, this one doesn't end. It just keeps going. That's fine. All we say is infinity with a parentheses. Okay, so the right side is unbounded. Okay, that's how you would, if you saw something like that, that's how you'd refer to it. It's unbounded. Okay. Now looking at the other two, I can tell that's not going to be the case for these. These look like they are bounded intervals. again, it's worth noting, like as far as what the instructions are saying, to convert each inequality to interval notation, I technically don't need to graph it on a number line, okay? That's just a thing that I'm doing because I think it's good to do, right? So you can kind of visualize what's going on. It's in between -1 and 6. Open circles for those on the number line. It's not including those points, okay? Now when I go to my interval notation, this interval is -1 to 6. What notation do I use to say that, hey, the actual numbers -1 and 6, don't include them. This is just strictly the numbers that are in between. And it would look like that. In between -1 and 6, don't include those two numbers, all right? If I were to refer to this one, this is bounded. Now, technically speaking, when I say bounded, you could refer to either side. Like the first one, x greater than or equal to 3, you know, it's bounded on the left side, right? There's a point where the interval ends. It's unbounded on the right. This one happens to be bounded on both sides. Right here is 0. So we're up above 0. Here's 5 to 12. Solid circle on 5. In between, open circle on 12, okay? Again, we would say on both sides, this interval is bounded. We're going from 5 to 12 because of this symbol right here, include 5, don't include 12. Now, you didn't see that on the first slide, and I was just going over the definitions, but it can go like that, where, you know, one side gets a bracket and the other gets the parentheses, right? It works perfect for this case because I want my notation to say include 5, don't include 12. All right, here we're just going the other way around. And again, I know it doesn't ask, and if this were like a homework problem, you don't need to do it, but I'm gonna graph these on number lines. As we're going through them, I just think it's a good visual for you to have. Okay, so here's 0. That'll get marked with -4. Looks like we need to include -4, and then we want everything that's over to the left. I'm gonna do the other ones too. There's a shorter little interval just from 8 to 9. Should include the point 8, should include the point 9, everything that's in between. -2, include it. 11, include it. And there's everything in between. Okay. Now I'm switching over to writing it as an inequality, okay? This would say x less than or equal to -4, okay? Remember, these two things are saying the same thing, all right? This is what I was saying at the beginning as far as like, you know, whichever notation you have to use, feel free to use whichever, right? Those two statements, this and this, are saying the exact same thing. So when you have a bounded interval, you tend to see that notation. Okay, that means x is in between, and then I can just put the boundaries for what x is in between. In this case, 8 and 9. Notice it's got like the The symbols down below that say to include, 8 and 9 with those lines underneath the less than signs. Should say one less than, one greater than. All right, and right here, very similar to that one in blue. -2 to 11. And again, make sure to include both the endpoints of -2 and 11. All right, let's go over how to solve some inequalities. Okay. This is, I like when I was solving equations in 1.2 and 1.3, I didn't address this specifically, but this is the way you've always seen me do it, that I keep the variable on the left side. With inequalities, I think it's even more important to do that. You're separating your constants and your variable. Constants go to the right, variable to the left. Constants to the right, variables to the left. If you multiply or divide by a negative, flip the sign. That's really important. You'll see it come up in one of these. Always write your compound solutions from least to greatest. Okay, so I'll show you when that comes up. It's saying if you have like a closed interval, and in fact, if you go to the previous slide and look at those two, those were compound solutions, right? Like between 8 to 9, between -2 and 11. Make sure to write those from least to greatest, that the lower number should be on the left and the bigger number on the right. Okay. So here I'm going to take away 3x. And I will get 2x minus 7, right, is greater than 9, right? So it's kind of like we're solving an equation, but it's technically an inequality. Right now it's saying that we need solutions that would make the left side bigger than the right side. 2x is greater than 16. Divide by 2. And for each one of these, I will write the answers in both, okay? If you wanted to leave your answer like that, you could say, oh, x is greater than 8. If you wanted to go with that interval notation, 8, don't include it. It'd be unbounded, and you could go all the way up to infinity, okay? Again, one or the other. Don't feel like you have to get in the habit that, oh, I got to go write both of them. Whichever you prefer. All right, the middle one, I just don't like the look of that fraction, so I'm going to multiply the whole thing by 2 and get 2 minus 3x is greater than or equal to 2x minus 8. Once I do that, it basically turns into the first one. Or at least the problem is very, very similar. Again, first things first, I like to get the variable over to the left. 2 minus 5x is greater than or equal to -8. Go ahead and take away 2. All right, here's a big thing. Need to scroll down for some more room here. First time we've seen it come up. Right now, as it, if we were to read the expression we have, it says -5x is greater than or equal to -10. Okay, I'm about to divide by a negative. Sign needs to flip. Okay, went from a greater than or equal to a less than or equal to. Okay, if you wanted the interval notation, could go all the way down to negative infinity. It's unbounded, right? Anything less than or equal to 2. So on the right side, it's bounded, but 2, notice it gets a bracket with it, include 2, because it's a solution. All right, last one. This is going to get you to what we call a compound solution. Notice it's got the 2 inequalities and the x is in the middle, right? So what I'm expecting to get is a solution that's bounded on both sides. It's going to tell me, hey, x has got to be bigger than this number and smaller than this one, right? It's in between these two. It feels kind of weird, but you can sort of treat it the same. I'm like, okay, add 1, usually like we're used to, we need to add 1 to get rid of that minus 1. I do it to both sides, but here it's like there's 3 sides. Go with it. It works. Negative 2 less than or equal to 6x, which is less than 4. Trying to get x by itself, which I'm trying to get x by itself and just kind of leaving it in the middle, which I'm fine with. And once x is by itself in the middle, we're done. We've got it. X has got to be between negative 1/3 and 2/3. If I were to go with the interval notation, in between those, do not include negative 1/3. Whoops. On second thought, I think I should. Do include negative 1/3. Don't include 2/3. Okay. Okay. Might have a couple questions on that last one. Again, when it's compounded and x is in the middle, try to keep it as straightforward as you can when you see those in the homework. That you keep working with them, kind of, getting x by itself in the middle, I think, is the best approach to take.